Alright, in this video we're going to talk about periodic trends. And a periodic trend is not what the latest fashion that the atoms are wearing, whether they have Louis Vuitton or Gucci or Juicy Couture. So whatever. But what a trend is, it's a pattern in certain characteristics such as size, and that's the first one we're going to look at. We're going to take a look at atomic size and how those characteristics change with regards to the periodic table. So what I have here, I have the pictures of what the atoms look like. This is arranged as they are in the periodic table. And you might notice some patterns. And so as you go from left to right across a row, you probably are noticing a pattern that the size of the atoms decrease. Okay, so we can summarize the size trend. Excuse me, I got something in my throat. Going this way, size decreases. Okay, so as you go from left to right, size decreases. And the reason size decreases, if you have to think about an atom, you think about, we have the nucleus here, it's got a bunch of positive charges. And outside that nucleus, we've got our electrons, and they're in an energy level. Now remember, that energy level is not an orbit like a planet, but it's a space where the electron might be. But as you go from left to right across the periodic table, what you're doing is you're adding a positive charge each time you go over one element, which means the nucleus, and this is not to scale, the nucleus is almost, it's 99% of the atom is the electrons in terms of size. So I just made the nucleus much bigger than it really is to kind of help see this. As I added that extra positive charge now, the electrons are going to be attracted even more towards the nucleus. And so that electron cloud will shrink and now maybe only be that big. And so that's what happens as you go from left to right. The proton number increases, the electron cloud gets attracted more and more. Now, as you go down, let's do it in black. As you go down, you might notice that size increases. So as you go down, the atoms get bigger and bigger and bigger. And the reason is because as you go, let's get rid of that. No, can't do that. Is as you go down, each time you go down a row, like say N8 to K, now you're adding another energy level. So as we go down a row, we add an energy level. The atom obviously will get much bigger. And that's why that we have this size trend. Okay, so some questions that you'll be working on in class will be like, what is bigger? Magnesium or strontium? And you'll have to look where they're at in the periodic table and realize that strontium is below magnesium and it is bigger. Alright, that's our first trend. Alright, so the second trend we're going to look at is what is called ionization energy. So I don't want to do blue, I want a black. I just want a black. Alright, so let's do ionization energy. So what is ionization energy? Well, ionization energy is the amount of energy it takes to remove an electron from an atom. So if we have some element here, the ionization energy is how much energy it takes to get an electron away from it. So let's look at our general trend for ionization energy. And you see this abbreviated as IE. So as we go to the right, IE will increase. And the reason is similar to the reason for size. So as we go from left to right, the atoms get smaller and smaller and smaller and smaller. But what's happening is the nucleus in each atom is getting more and more and more positive. So as we go across, this might be a 3 plus, then a 4 plus, the nucleus, and then a 6 plus nucleus, and a 7 plus nucleus, and so on. And so not only are the electrons getting closer to the nucleus as we go from left to right, but the nucleus is getting more and more attractive. So it will take more energy to get an electron away from this atom than it will from this atom. So the leftmost atom in any row has the lowest ionization energy. It's the easiest to take an electron from it. What's the pattern as we go down? Well, as we go down, ionization energy decreases. And the reason, again, as we go down, the atoms get bigger and bigger and bigger. So the outermost electrons, the valence electrons, right? We're only worried about the valence electrons most of the time. Those valence electrons are now far away from the nucleus. It's much easier for another atom to come by and to pull off an electron. It does not take much energy. And so this is our pattern for ionization energy. Okay, our last trend that we'll look at in this video is a trend called electronegativity, and it would be this. If we had two atoms, and this atom had a few electrons here, and this atom had a few electrons here, electronegativity would be the strength with which an atom can attract electrons from another atom. So the red atom might have electronegativity strength like that, but this atom might have a very small electronegativity. And so the red atom is able to pull the electrons off. So we would say that this would have a greater E than this. So E red would be greater than E black, because if you look at it, the red is able to pull the electrons from the black with a greater force than, if we go by length of arrow, I guess can determine strength. The black atom, much smaller arrow, so we would say this atom is better at attracting electrons. So in the periodic table, the trend for electronegativity, so we'll do electronegativity. So go left to right. Smaller atom, as you go left to right, the atoms get progressively smaller, which means the nucleus of the atom is closer to the outside. If the nucleus is in the middle, it's much closer to the outside where another atom might be. And so the smaller an atom gets, the more it is able to attract electrons from another atom. So for this we say electronegativity increases, and then as you go down, right, so the atoms are getting bigger and bigger and bigger. Now the nucleus is in the middle. There it is. Here's an atom over, let's say there's another atom over here. Well, here so if here's an atom and here's an atom, the nucleus of this atom is much closer to the electrons than the nucleus of this atom. So this atom is stronger at pulling electrons than this atom. So as you go down and the atoms get bigger, electronegativity decreases. And so those are the three main trends that right now we're worried about. So in class tomorrow, for your SSS, you'll be able to work through and answer some questions about atomic size, ionization energy, and electronegativity.